Okay, so today we need to cover the compressible fluid flow, right? So guys, we'll discuss in a very beautiful manner that what are all the basic things that we need to cover with respect to compressible fluid flow, right? Now, so before development of understanding this, compressible fluid flow, I just want to tell you guys what is the actually meaning of the compressible flow. So just note down very one line: flow that involves a significant change in density. Such a flows are called as compressible flow. Just note down, very important. So definitely today's discussion will be very important with respect to I will try to revise thermodynamics as well as fluid mechanics also, so that it will be connected with each and every subject, and you will be having interest also. So before understanding the compressible flow, we will discuss about the compressible and incompressible, because in your whole fluid mechanics you might have assumed only the incompressible fluid flow, right? But we can discuss about the uh, about the compressible flow also. So what do you understand by the compressible and incompressible? Tell me, guys. So there are four terms that is very important. At the end of the today's lecture, you must able to understand all these four terms. First is incompressible fluid. Then incompressible flow. Then compressible fluid. So we have only two classes for this one. This is the first class in which we are going to cover basic till basically normal shock. After that, normal shock, oblique shock, and the expansion wave shock that we are going to cover in the next class, along with the convergent divergent section. Then we have the compressible flow of fluid, you can say, and D will be what? Compressible flow. So many times confusion will be there among these four terms only. Frequently you come across any textbook, any standard textbook, then you might have feel that always you will be feeling that, sir, sometime I used to find incompressible fluid, sometime I used to find incompressible flow, sometime I used to find compressible fluid, sometime I used to find compressible flow. What is the actually similarity or difference between these four terms that we are going to explore now? So tell me, guys, if I'll be just asking you, what do you mean by the incompressible fluid? A very first term that I will be introducing, incompressible fluid, and you must be very familiar. Incompressible fluid. So example, if I'll ask you example, definitely you can say water. But apart from the example, what is the definition actually? See, fluid mechanics already covered. Yes or no, guys? Whether fluid statics has been covered or not. Fluid property, fluid statics, and before fluid kinematics. Okay, then you can easily answer. I think there only we have discussed about the incompressible fluid. There we have defined one term. By means of that term, we are saying that if it is infinite or if it is finite, then what is the categories of fluids? So can I say incompressible fluid means directly K will be infinite? Now you will ask me, sir, what is the K? Again, you will ask me, sir, what is the K? K is what? Bulk modulus of elasticity, right? Yes or no, guys? Perfect. Bulk modulus of elasticity. That is called K. Now, what is the definition of the K? dP divided by minus of dB by V. That means K is basically defined as the normal pressure or the normal stress divided by what? Volumetric strain. Divided by volumetric strain. Always fluids are subjected to compressive stress rather than they are subjected to what? Tensile stress. Fluid will always be subjected to what? Compressive stress. Apart from this fluid, suppose you are talking about the solid can be subjected to shear stress, it can be subjected to tensile stress, it can be subjected to compressive stress. But most of the time, 99%, or you can say that 55%, 45% time you will find that the fluids are subjected to what? Compressible forces, compression forces, as well as they are subjected to what? Shear forces, right? Now, So K will be infinite means what? Can I say volumetric strain for the water, for this fluid? Can I say volumetric strain or change in volume by original volume will be 0? Tell me guys. Can I also say that d rho by rho will also be 0? Because what is the mass? Volume into density. Now if I differentiate, mass cannot be variable quantity, it can be fixed only. So V into d rho plus rho into dV, that must be 0. So d rho by rho will be what? Minus of dV by V. So if that's going to be 0, this is also going to be 0 for the water. And that's the reason, my dear friend, if it is this term is 0, then this term will be infinite. Am I right? Tell me guys. Perfect. But the moment I will be asking you incompressible flow, the moment if see these are the very few minute, very micro differences there between these two. Sometime you might be thinking that incompressible fluid will always be incompressible flow. Yes, you are correct. But the definition about saying the incompressible flow and incompressible fluid is different. If somebody will be asking you what is the meaning of incompressible fluid, you must say bulk modulus of elasticity is going to have a large value. How much large value? Infinite value. But if somebody will be asking you, sir, what is the meaning of incompressible flow? Then you must answer like this. Volumetric strain rate must be 0. Sir, what is a volumetric strain rate? Volumetric strain rate, you know that it's a summation of the linear strain in x direction, linear strain rate in y direction, and it's also the summation of linear strain in z direction. Let me write once again. Volumetric strain, I think you have studied the strength of material also, right? Strain in x direction, strain in y direction, strain in z direction. They must be equal to 0. Sir, what is the definition of the linear strain? Can I say dou u by dou x plus dou u by dou y plus dou omega by dou z must be equal to 0? That is the meaning of what? Incompressible flow. Note on guys, very important. These are the very basic different but very important difference. Please note down. Incompressible fluid means density will be constant. The density will be constant. That is what incompressible fluid. But if I just say compressible fluid, if I say compressible fluid, density will not be constant. Am I right? Tell me guys. All of you, please let me know. Perfect. So please note down. After that, we are going to discuss one more important discussion on the compressible fluid and compressible fluid as well as compressible flow. Just hold on. Yeah. So now some of you might be thinking, sir, we never come across any difference between incompressible fluid and incompressible flow. They must be same, right? Now, let me ask you one question: whether both are same or not. Incompressible fluid will be just incompressible flow. Tell me, guys. But that is always guarantees there whenever there is a incompressible flow is there, that will always be incompressible fluid. Two questions I'm asking. If there is an incompressible fluid, that fluid whenever it is flowing, that will always be remain in incompressible flow. But one more question is there. If suppose any cross section or any suppose any places where incompressible flow is there, that will always resemble the incompressible fluid, or can the incompressible flow be the compressible fluid also? Understanding what I'm asking? Let me just summarize. Do not confuse. Just see. I'm asking that incompressible fluid will always incompressible flow. That is the first statement. Second statement, incompressible flow will always be incompressible fluid. Now tell me, guys, whether true or false, you need to tell me. I have given the option 1 and 2. That means the statement I have given 1 or 2. You need to just say me whether first is true or second is true, first is false or second is false. Most fundamental thing before discussion of the further about the compressible fluid flow, you must be able to understand between the fluid as well as flow. That's a very important, guys. Now somebody will be asking me, sir, what is the meaning of incompressible flow? The flow that has zero volumetric strain rate the flow that has zero volumetric strain rate is called as incompressible flow. Note down, is called as. Now those who have noted down the definition, please look at back to the question. Is called as incompressible flow. Tell me, guys. Very important. So again, I'm hoping that all of you are understanding. All of you understood the continuity equation, right? Generalized three-dimensional Cartesian coordinate continuity equation. All of you are aware of those equations? Fluid mechanics. All of you are aware of those equations? So Naveen, whatever you are saying, that is, try to reverse it. First is false, you are saying. Second is true, but that is not correct. First will always be true, and second will be not true always. Sometime it can be incompressible fluid, but sometime it can be what? Compressible fluid also. Understanding? So we will understand. We will try to explore these things. Do not worry about those things. So now once it is done, let me know. All of you have noted down? So today's lecture will be just an eye opener for whatever the reality is there actually. Whatever the Bernoulli equation and whatever the fluid mechanics we have learned, that is actually what hypothetical assumptions we are making, that always the things will be incompressible, but that is not true always. Now done, all of you? Remaining guys are understanding or not? Any difficulties? I'll make sure that all the concept you must be able to understand by the end of today's lecture. Do not worry. Done? Done, all of you? Remaining guys are there? Remaining guys are there? What about those guys, those remaining guys, Praveen as well as Praveen Kumar? Are you understanding or not? Tell me, guys. I'm not able to get any response from both of you guys. Yes? All of you can hear me? Okay, fine. But that is fine. But are you understanding or not? Okay. Now try to understand. I'm writing the continuity equation, and I believe that you must be able to understand this continuity equation very thoroughly. Three-dimensional Cartesian coordinate continuity equation. So whatever actually we are learning, that is just extension of the whatever the chapters that we have concluded, right? So if I just write the continuity equation, so dou rho by dou t plus dou by dou x of rho u, rho v, dou by dou z of rho omega, that is equal to 0. Now if I try to explore this thing, my dear friend, if I try to explore, then dou rho by dou t, u into dou rho by dou x plus v into dou rho by dou y, omega into dou rho by dou z, that is the one term, plus rho into dou u by dou x, dou u by dou y, and dou omega by dou z. U v omega is what? Velocity vector. Velocity vector is what? U y cap plus v j cap and omega k cap. This is what the velocity vector is there in three-dimensional Cartesian coordinate system. That means along the x-axis, along the y-axis, along the z-axis. All of you are aware of this equation or not? These two equations. From here only we are getting what? This equation. This is a three-dimensional continuity equation. Perfect. Perfect, my dear friend. If I say from here I can conclude two things. What are the two things I can conclude from here? One, there is an incompressible fluid. Suppose there is an incompressible fluid. That means density will be constant. If density will be constant, my dear friend, if anything will be constant, either you differentiate with respect to time or you differentiate with respect to any space coordinate, will be 0. Am I right? Will be 0, right? Check it out. Please check it out. All of you, please check it out. If that going to be 0, this term will be 0. This whole term will be 0 for this, basically this particular fluid. Whole this term will be 0 for this incompressible fluid. That means what we can resemble from here? We can get from here dou u by dou x plus dou u by dou y, dou omega by dou z equal to 0. Indirectly, we are just moving towards volumetric strain rate to be 0. That means whenever any fluid will be incompressible fluid, will always be what? Incompressible flow. Will always be incompressible flow. Remember, we are talking about the flow. That means per unit time, the things are changes very frequently. That's why we are defining not volumetric strain. We are defining volumetric strain rate, because volumetric strain, this term is more significant in solid mechanics. There is a fixed amount of deformation is there. But here, even though you apply 1 Newton of force, the fluid element is such a way that it is keep on deforming, right? In the fluid, particularly fluid mechanics, in the first chapter, you might have learned about the properties of the difference between solid and fluid. The fluid is a such element which deforming continuously under the action of a small shear force, right? So please note down, whenever any incompressible fluid will be there, it will always be incompressible flow. But the second side of the story will be, if I just say compressible fluid, if I'll say just a compressible fluid, just wait. If I say just a compressible fluid, then what will happen with this particular compressible fluid? What will happen with this compressible fluid? The density will not be constant, right? When density will not be constant, my dear friend, then dou rho by dou t will not be equal to 0. Dou rho by dou x will not be equal to 0. Dou rho by dou y will not be equal to 0. Dou rho by dou z will not be equal to 0. Am I right? Check it out. If it is not constant, we don't know whether it is a function of x, y, z or time. Whether it is a function of x, y, z or time, we don't know. So we can say that dou rho by dou t will not be equal to 0. Dou rho by dou x will not be equal to 0. Dou rho by dou y will not be equal to 0. Dou rho by dou z will not be equal to 0. In that case, we will not be able to conclude if this particular term will not be 0. This particular term will not be 0, my dear friend. How can you say that volumetric strain? This term is what? Volumetric strain rate. In that case, there is a two possibility. There's a two possibility. One possibility will be volumetric strain will not be 0. Second possibility, volumetric strain will be 0. But sir, how? They may not be equal to 0, but suppose this value is -2, this value is +4, -4, +2. They will be getting the value, non-zero value in such a way that they will cancel out each other and volumetric strain will be 0. Understanding my point? Or they will be having such a non-zero values so that they will not cancel out with each other and they will not be equal to 0. If that will not be equal to 0, this term will not be equal to 0. This term will also be not equal to 0. In that case, volumetric strain will not be equal to 0. And if that is so, then this is called as, compressible flow. And this is nothing but, that incompressible flow. So compressible fluid will never guarantee the flow to be what? Compressible and incompressible. It can be anything. But if there is an incompressible fluid, it will always guarantee you that you will be getting what? Incompressible flow whenever it is flowing. Either it is flowing flow over the flat plate or it is flowing flow through pipes. Check it out. All of you, please check it out, whether you are understanding or not. So these things are basically, if you try to learn, suppose Frank M. White or Singhal, Eunice Singhal book, or maybe any other book, T.K. Naik, or maybe some other book, K.L. Kumar, you will not find that much clarity actually, even though they have given each and everything in detail, but you need to read multiple times. Again, you need to waste your time, lot of amount of time in searching whether it is a compressible flow. Sir, what is the meaning of incompressible flow? That's clarity is not there when you read the textbook, right? Even though standard textbook, even though you watch the NPTEL videos also, that is my challenge, you'll be having difficulties, because when I used to learn these things, I'll be having most challenging tasks to find the difference between this type of fluid and flow, right? So that's the one common conclusion we can give. Incompressible fluid will always be incompressible flow, but compressible fluid will no guarantee that whether the flow is incompressible or not. It can be both. It can be compressible or it can be incompressible flow, right? Note down, guys. That is the same confusion you have as you have the confusion in, ideal fluid and ideal flow. So can I ask you the difference between ideal fluid and ideal flow? Both are hypothetical things. In reality, we never exist. We never seen ideal fluid and ideal flow. We may not seen the ideal fluid, but you might have observed the ideal flow. All of you can tell me the difference between these two. Ideal fluid, most hypothetical case, but ideal flow, sometime what? We can say that realistic condition it can be, right? Tell me, guys. Yes. So can I move to the next slide? Try to participate, guys. Very, very important session we are just going through actually, right? Now, because once you got the, once you will be getting interest why we are learning this compressible fluid flow, then the moment you cannot stop yourself to being quick learner about this particular topic called compressible fluid flow. Suppose if I'll just feed you a lot of things, a lot of hypothetical or maybe futuristic story in front of you, that we are going to learn these things, and before that these are the basically reason for that purpose we are learning these things, then you will be you cannot just wait for that moment that you will be getting something idea, that you are just waiting for whole fluid mechanics actually. starting from the bulk modulus of elasticity, when you are learning that particular term, there only the terms has differentiated two types of flow or two types of fluid, that is a compressible fluid and incompressible fluid. There itself you will be having a lot of curiosity about those things, right? Yeah, so all those curiosity, right, that will be clear by today's lecture. That is my guarantee. Now, whether it is done, all of you? All of you have noted down? Perfect. So before development of this speed of sound, as well as, what we can say, anybody know the difference between ideal fluid and ideal flow? Anybody know the difference between ideal fluid and ideal flow? So note down, guys, we have the fluid. The fluid can be compressible fluid. The fluid can be compressible fluid. The fluid can be incompressible fluid. Or the fluid can be compressible fluid also. The fluid can be incompressible fluid. The fluid can be compressible fluid. Suppose incompressible fluid is there, then it will always resemble incompressible flow. That will be same as incompressible flow. That means now onwards, remember that whenever the density changes will be less than 5%, that type of fluid flow we call incompressible fluid flow. Note on, guys. Wherever the density changes will be less than 5%, we say that it is an incompressible fluid, or we can say that incompressible fluid flow. On the next hand, what we have? Compressible fluid. Compressible fluid can be have the two categories. It can be have the compressible flow. The compressible fluid can be compressible flow. In that case, change in density will be more than 5%. More than 5%. Or we can also say Mach number will be more than 0.3. In this case, we say Mach number will be less than 0.3. What is the Mach number and all? We will discuss. Do not worry. Do not worry. Second thing, we have the compressible, incompressible flow. When I talk about the incompressible flow, again, even though the fluid is having a lot of density changes, but that density will not be changes more than 5%. It will be less than 5% only. That means Mach number will be less than or equal to 0.3. Such a fluid flow will call as compressible fluid and incompressible flow. Note on, guys, very, very important. Even though fluid is compressible, even though the density has been changes, but that changes will not be that much high, will not be more than 5%. If it is a more than 5%, we say it's a compressible flow. Understanding what I'm saying? Tell me, guys. So note on, guys, very, very important. So here only you just note down what is the meaning of Mach number. In fact, we will discuss in detail about this Mach number and all, but just note down Mach number. What do you mean by the Mach number? Velocity of the fluid flow. Velocity of the fluid flow divided by velocity of sound. Velocity of the fluid flow divided by velocity of the sound. That means we say V by C. Speed of the sound, the same speed of the light, 332 meter per second or 340 meter per second or 336 meter per second. That is what you are observing, the values. That is the same value. The velocity of the sound or velocity of the fluid flow, the ratio is called Mach number. Right? Very, very important. So we have many types of flow, guys. We have incompressible flow, we have the compressible flow, we have subsonic flow, we have sonic flow, we have transonic flow, we have supersonic, we have hypersonic, lot of flows we have. Done, all of you? All of you have noted down? So all of you want me to discuss about the ideal fluid and ideal flow, or you already have the idea? Because fluid mechanics already is going on, maybe about to finish. Then you might have know about the ideal fluid and ideal flow. So you want me to discuss again, or is it fine if I'll not discuss? Tell me, guys. Yes. So, okay, I'll be discussing in short so that you'll be having very good idea about those things, right? And I think I know that you might be aware of those things, ideal fluid and ideal flow, right? Yeah. So try to understand. So very first of all, we will try to learn the difference between the ideal fluid. Why I'm saying, see, these are the very hypothetical thing, ideal fluid and ideal flow, but it's still very important. Because whenever the moment you are entering into the interview hall, they'll be start giving you the paper, and they will say that the flow of fluid is there on the what, you can say that flat plate, and the flat plate is suppose that fixed one. And the moment they say that, again they will ask you the velocity profile over that, and you will say, sir, we will be getting like this. You will be saying something like this, sir, because of the bond delay formation and all kind of stuff. You will be start saying, the moment you draw the velocity profile, the very next question will be whether you are drawing for the real fluid or ideal fluid. Suppose you will say, I'm drawing for air. Air is what? Air is a real fluid. Air is a real fluid. You can say that ideal fluid, right? But in fact, air is having what? Viscosity. If air is having viscosity, that means it is coming under a real fluid. Or gases, you can say. If the gases you are considering, that is a real gas or real fluid. But the moment you will say that is a real, that is correct. But the next question will be, can you draw the velocity profile for the ideal fluid flow? Then that will be the difficult task. So you need to understand each and everything in detail. So note down ideal fluid. Ideal fluid means the fluid for which ideal fluid means the fluid for which bulk modulus of elasticity will be infinite and viscosity will be 0. If these two terms are there, if these two particular characteristics of that particular fluid is there, then we say it's ideal fluid. What is the mu? Mu is nothing but viscosity. And you know that in reality, no fluid is having what? We don't have any fluid that is not having any viscosity. All the fluid will be having some kind of viscosity, even though it is a very, very low amount, but still it is having viscosity, right? Again, the next term will be ideal flow. So what is the meaning of ideal flow? Note down. Ideal flow is nothing but volumetric strain will be 0. Ideal flow means incompressible flow. Indirectly, you can say. And incompressible flow means what? Volumetric strain rate will be 0. And of course, tau will also be 0. Tau means what? Note down, shear stress. Very, very important, guys. So, in generally, suppose if I'll say inviscid fluid, if I start my discussion from inviscid fluid, then I will say inviscid fluid means viscosity will be 0. Viscosity will be 0. That means tau is what? From the Newton's first law, Newton's law of viscosity. From the Newton's law of viscosity, tau is equal to what? Mu into dou u by dou y. If this thing will be 0, tau will automatically what? 0, my dear friend. Tau will be 0. That will resemble what? Inviscid flow. So whenever inviscid fluid will be, always be inviscid flow. Understanding my point? If it is an inviscid fluid, it will always be inviscid what? Flow. But in contrast to that, in against of that, we have another conclusion that I can make. If suppose you are taking free stream flow, you are taking. Suppose you are taking free stream flow. Free stream flow means what? Free stream flow means the velocity profile for which it will be something like this. means each and every fluid layer will be having same kind of velocity. du will be 0, du dy will be 0, mu will not be 0. See, mu will not be 0. This is the ideal. Suppose this is a real fluid. This is nothing but a real fluid you are taking for which mu is not equal to 0. But due to some circumstances, it is making a velocity profile to be something like what? Like this. I can say that the whatever the flow is approaching towards this particular flat plate is what? Free stream flow. Am I right? Above the boundary layer or in front of the boundary layer, the moment it is touching the flat plate, that is a free stream flow, right? And that is what the surrounding air is what? Having viscosity that is not equal to 0. You can check in the Google. Just search what is the viscosity of the air. That will not be 0. That is going to have some particular value. Viscosity is not equal to 0, but because of that, tau will be what? Again 0, because du by dy will be 0. That means what? Tau will be 0. So again, it is just resembling like what? Free stream flow is resembling like ideal flow. Note on guys, very, very important. Ideal flow because tau is what? 0. Very, very important guys. So is that clear? The difference between ideal flow and ideal fluid? Okay. So both are not same, both are different, but ideal fluid will always be ideal flow, right? Now, once it is done, let me know guys. Perfect. Perfect. Note down speed of sound and Mach number. Sir, what do you understand by the speed of sound? Anybody know the idea about this thing? You always say the velocity with which the light is flowing in a pockets form, or maybe physics of quanta or quantum mechanics. You might have learned the basically the photons or packet or the bracket in the lights are flowing in the what in terms of always flowing in terms of what bracket or maybe pockets. The velocity of that particular light we always say is speed of sound, or speed of light we always say that is speed of sound. It is having some particularly value as roughly around 332 to what 336 meter per second. But what is the physical meaning of speed of sound with respect to fluid mechanics? Tell me guys. With respect to fluid mechanics, if I'll be asking you what is the meaning of speed of sound, then what you will say? So for understanding those things, let me discuss one beautiful thing about the speed of sound. Suppose that you are taking a piston cylinder arrangement. I remember speed of sound is having some significance in compressible fluid, not in incompressible fluid flow, not in incompressible fluid. Why? That also we are going to learn. My dear friend. Do not worry. So yeah, try to understand. There is a piston cylinder arrangement. Now this cylinder is fitted with the piston. This particular cylinder is fitted with the what? Piston. This particular cylinder is fitted with the what? Suppose that piston. So what is this piston? This is what we have cylinder, my dear friend. Now try to understand. Suppose here we have the fluid. Any fluid. I'm not taking the compressible or incompressible. I'm just taking fluid. Maybe you can consider compressible fluid. Now, the moment you are trying to press this piston in this positive x direction, it is going to compress. This particular fluid is going to be compressed. The moment you are going to compress it, then suddenly what will happen? There is a kind of wave will propagate through the fluid medium. What will happen? The moment you move the piston, if we move the piston, then there is a movement of pressure wave or pulsating wave, or we say elastic wave through the fluid medium. Then pressure wave or elastic wave will be propagated through the fluid medium. Suppose somebody is not able to digest, sir. We already learned the piston cylinder, I mean the thermodynamics also. There we never come across, apart from the pressure and whatever the temperature, we never come across this pressure wave or elastic wave. See, whenever you try to compress it like this, then there is a one kind of disturbance wave is there that will propagate. The disturbance wave, it is kind of what? Disturbance wave. It is kind of disturbance, you can say. That disturbance will propagate along with the what? The movement of the piston. The speed with which this pressure wave at this disturbance is propagating, that is called speed of sound. No, guys. The speed with which this fluid is flowing, suppose that velocity v, and speed with which this disturbance is propagating, that is having some significance correlation between this velocity as well as speed of sound. And that is what we are learning in this particular chapter. So please note down the speed with which this pressure wave and the elastic wave propagate through the fluid medium is called speed of sound. And the formula for the speed of sound will be, C will be under root of dou p by dou rho under what we are writing, dou p by dou rho constant entropy condition. We say isentropic condition. Now tell me why we are calculating the speed of sound, why we are calculating the disturbance in absence of any irreversibility and any inadiabatic conditions. What is the meaning of isentropic flow? What is the meaning of isentropic process? What do you mean in thermodynamics about the isentropic process? Any process is called as isentropic process or what? There is some specialty about this process. Can I say reversible plus adiabatic process? Is called as isentropic process. Reversible plus adiabatic process, can we call this to be isentropic process? So if I say this statement, two statements is there again, I'll be asking you two questions, two statements, true and false. All the reversible and adiabatic process are always isentropic process. That is the first statement. Second statement, all the isentropic process are always reversible and adiabatic process. Tell me guys. Statement 1 and 2. Statement 1 is there. All the reversible and adiabatic process are isentropic process. That is the first statement. That is the first statement. All the isentropic process are reversible and adiabatic. That is my second statement. Now tell me whether first statement is true or false. Second statement true or false. Try to participate. These are the very, very important terms, guys. Tell me, guys. Change in pressure with respect to density. How much pressure we are applying with respect to that, whatever the density changes will be there under isentropic process. That is nothing but what? Speed of sound. But before that, let me know whether you have understood about this isentropic process and reversible adiabatic process or not. That is what I'm checking. Tell me, guys. Yes, I'm not getting any reply. Thermodynamics. I'm asking you, all the reversible and adiabatic process are isentropic process. That is my first statement. What I'm asking, I'm just writing. All the reversible and adiabatic process are always isentropic process. That is my first statement. Second statement will be all the adiabatic process, all the isentropic process are always reversible and adiabatic process. Tell me guys, this is what statement 1 and 2. You need to tell me true or false. So first is true, that is correct. What about the second statement? I want the answer from all of you guys. You guys are there, please try to respond. Praveen and Praveen Kumar, all of you. Do not sit idle guys. Try to respond as quickly as possible. Yes. Tell me guys. Quickly. Remaining guys. Second statement, my different false. Why second statement is false? Why second statement is false? There is a reason for that. Let me explain you the reason. What is the total entropy change for any process? dq by t plus entropy generation. Entropy generation. Delta S of any system will be called as dq by t plus entropy generation. That is what from the second law of thermodynamics, right? That is what we learned from the second law of thermodynamics, guys, right? If I'll say reversible, reversible means what? Entropy generation will be zero. There will not be any friction, frictionless process. There will not be any friction, frictionless process will be called as reversible process. This term will be zero for reversible. What about this term will be zero for adiabatic? This term will be zero for adiabatic, my dear friend. So in short, both will be zero. We can say this will also be zero. An isentropic process is that process where total change in entropy will be zero, my dear friend. Total change in entropy will be zero. That is about the first statement. Now move back to the second statement. They are saying all the isentropic process, that means ds equal to dq by t plus entropy generation. This will be zero. My dear friend, this can be zero when this will be minus 5, this will be plus 5. Through that also it will be zero, or this will be zero, this will be zero. In that also it will be zero. But in this particular segment, suppose you are talking about the first case where there is a transfer of heat from the system to the surrounding by the amount 5 kilojoule per Kelvin, and there is some kind of friction. Because of that, there is some kind of heat generation is happening of what? 5 kilojoule amount per Kelvin. Together they will cancel out, again that will be zero. So all the isentropic process, that means for ds to be zero, that will never be guaranteed that it will be reversible and adiabatic, because here it is what? With respect to this, you are saying that non-adiabatic process, right? It's a non-adiabatic, and because it is 5, entropy generation is more than 0, that means what? It's irreversible phenomena. Not reversible. Am I right? All of you understanding the subject or not? That's why I told you before moving to this particular compressible fluid flow, you must understand or revise thoroughly about the thermodynamics and fluid flow. Because not believing, my dear friend, I'll be proving one statement, stagnation enthalpy. There I will challenge you. Most of you will be confused about the adiabatic process and isentropic process. So those who are saying adiabatic process always isentropic process, incorrect. Right? Because irreversibility can also make the system to be what? Non-isentropic process, right? So please note down few basic about the thermodynamics. Is it done, all of you? Done? So note down, speed of sound will be defined as dp by rho under isentropic condition. Now the question will be why we are calculating this dp by d rho under isentropic condition. When the entropy is constant, then why we are calculating this speed of sound? Because in that case, frictionless process there. In that case, adiabatic process there. That means we are just in an environment where there is no friction, there is no heat transfer is happening to the surrounding. So whatever the true nature of the speed of sound or true nature of the disturbance is there, that can be get it. That can be basically we can get it from the system. If there is a friction, the friction wave will also propagate. If there is a heat transfer, that will also seen along with this disturbance propagation. So the true nature we cannot expect from the disturbance, that what is actually happening through that particular system. But if there is a frictionless process, when there is a no friction, when there is a no heat transfer, completely insulated system is there, in that case we can just see the true nature of the disturbance. That's why we are calculating. In fact, we can calculate under any condition. Under isothermal condition also we can calculate speed of sound. Under any condition, any process we can calculate. But most idealistic and most you can say that the beneficial research point of view, if you just say the under isentropic condition, if you just see the reality of disturbance, or if you just study about the motion of disturbance wave, that will be very good idea, right? So that's the reason we are just always say that the speed of sound will be what? dp by rho, dp by d rho under isentropic conditions. Please note down. Now we have to calculate the speed of sound in two conditions. One is what? Isentropic condition. Second is what? Isothermal conditions. So we have the two process: isentropic process, isothermal process. Before that, let me know once it is done. Before that, let me know once it is done. Done, all of you? Can I move to the next one? And of course, we have noted down about the Mach number. Mach number basically what? It's the ratio of the velocity of fluid to the velocity of sound. Now, so the ratio of the speed of fluid flow to the speed of sound is defined by the dimensionless number Mach number, V by C. Now, just we will try to prove the speed of sound, that is under root of dp by d rho by two process. One I am taking isothermal process. Under isothermal process, and second I am writing in under what? Isentropic process. Isentropic process. Under two conditions, we are calculating the speed of sound. We have to calculate dp by d rho, and that we are calculating for ideal gas. So we are going to use ideal gas equation. For the ideal gas equation, first of all, what we are going to learn, isothermal process, PV equal to constant. Am I right? PV will be equal to constant. In fact, PV equal to MRT. So P into V by M, that equal to RT. What is the V by M? Specific volume equal to RT. Can I write P by rho to be constant? T is constant. That means what? Can I write P by rho to be constant? P by rho to be constant. Perfect. Now try to differentiate. So P into -1 into rho to the power -2 into d rho plus rho to the power -1 into what? dp. That will be equal to 0. So from here, what is the dp by d rho? dp by d rho will be, my dear friend, it will be what? It will be bring back to the that side. This particular term will be bring back to the what? Right hand side. So from here, what we can calculate? Here, what we can calculate? So rho and this rho will one rho will cancel out. So dp by d rho under constant temperature process will be what? Tell me, guys. Can I say P by rho? So from here, what will be the C value? RT. Can I say RT? Because P by rho is what? P by rho is what? P by rho is what? RT. Check it out. So this is the speed of sound for isothermal process. Isothermal process. Now if I'll say about the isentropic process, that means what? P into V to the power gamma equal to constant. Here, this is a specific volume, so we can also write P by rho to the power gamma will be also equal to constant. Now, if we try to differentiate and all, you will be getting from here dp by d rho as, after differentiating, you will be calculating dp by d rho, and that will be coming out to be gamma p by rho. So C value for isentropic process will be under root of gamma RT, where gamma is what? Where gamma is what? Is specific. What is the gamma? Specific heat ratio. We also say what? Adiabatic index, right? Yes or no, guys? We also say adiabatic index, right? So these are the few terms that is coming from the thermodynamics you must be able to understand. So now we got the speed of sound, two formulas. One is for one is for isentropic process, and one is for what? Isothermal process. Done, all of you? Is it done? All of you done? All of you done? Yes. Now, before understanding this stagnation properties, we will come to understand gamma RT. Under root of gamma RT, what is the meaning of this? In this one, R will be what? It is a characteristic gas constant. It is a characteristic gas constant. And that is equal to what? Ru by capital M, where M is nothing but what? Molecular weight. So from here, what you can calculate? Speed of sound, you can calculate. The one conclusion. What conclusion you can make? If molecular mass will be more, then R will be less. R will be less, C will be less. That means lesser mass, more will be the sonic velocity. Lesser will be the mass, more will be the sonic velocity. Sorry, lesser mass will be what? More sonic velocity, or you can also write more mass will be having less velocity. Right? Speed of sound we also call sonic velocity. Right? All of your understanding? One more question they have asked in ISRO examination. What question they have asked? The speed of sound is more in a warm season or uh, cold season. In which case, that is hot environment or cold environment, two environments are given to you, and they will be asking you under which case the speed of sound will be more, right? So through that also you can answer. When the temperature will be more, speed of sound will be more for constant gamma and R, right? So this question they have asked in ISRO, I think 2016. Right? Now, once it is done, please let me know. Note down the stagnation property, note down the definition. What is the meaning of stagnation? I think while understanding the pitot tube, you might have understand the static and stagnation properties, right? Whatever the thermodynamic pressure is there, whatever the thermodynamic pressure, whenever the fluid is flowing or fluid is under the rest condition, whatever the pressure that has been acting on the fluid element is called static pressure. But the moment it is start flowing and suddenly it is bring back to the stationary conditions, at that case, whatever the fluid element is there, which is bring down to the zero velocity, at that moment, whatever the properties of the fluid is there, that is going to be called as stagnation properties. Either you say stagnation enthalpy, stagnation temperature, or you can say stagnation what? Tell me guys. Whatever the properties will be there, that will be defined when the fluid is brought to the rest isentropically. One important meaning is that we are bringing back this fluid to the what? Zero velocity. By which process? Isentropic process, right? All of you understanding the meaning of isentropic process? We are bringing back this fluid element to the zero velocity, not by isothermal, not by isobaric process, not by constant volume process. We are just bringing back this particular fluid element to the zero velocity by isentropic process, so that no other losses can be encountered. Because if we bring back to the what? Other adiabatic condition, then what will happen? Irreversibility will be there, friction will be there. Because of the friction, whatever the zero velocity benefit is there. See, what is the benefit of zero velocity? See, according to Bernoulli equation, P by rho g plus V square by 2g plus Z equal to constant. Suppose this is 0. If velocity will be 0, whatever the kinetic energy of the fluid will be there, that will be converted to pressure energy. So static plus another this term will be together called as stagnation. So what will happen if we are not bringing this particular fluid element to the isentropic manner? Suppose we are bringing to the non-isentropic manner, what will happen? The friction will contribute. Friction will be contributing, that means what? Whatever the amount that we transfer to the pressure energy, some amount will be transferred to the what? Friction energy also. So that much pressure rise will not be taking place. In that case, what will happen? True nature of the velocity profile or true nature of the velocity that we are measuring through the pitot tube cannot be occurred. Suppose this is the pipe in which we are placing one pitot tube and there is a piezometer, and we are measuring the fluid velocity, whatever the free stream velocity that has been flowing through this particular tube, we are measuring. Suppose we are measuring this fluid velocity, my dear friend. If there is a friction, what will happen? Because of friction, can we able to measure the true nature of the velocity, true value of the velocity? No, right? Tell me guys. Tell me guys. No, we cannot able to measure. That's the reason. That's the reason. You always observe, if there is a pipe, the pitot tube always placed at the center. If you just find the center line axis of this pipe, the pitot tube always placed exactly at the center line. That is also one of the very important interview question. Why pitot tube always placed exactly at the center? Because anybody know the reason? Already reason I told you. Whenever there is a friction, involvement will be there. Whenever there is a viscosity, things will not be same. That means the correction in the values will not be guaranteed. See, when you draw this velocity profile, the boundary layer formation will be forming something like this, right? You know that inside the boundary layer, the fluid is what? Very, very highly friction flow is there. highly viscous fluid is there. But in the core region, the fluid, whatever the boundary layer is there, that is going to be merged. And in that center line, there will not be any viscosity effect. That much viscosity effect will not be there. Why this viscosity effect is very, very high? Because of the what? No slip conditions. All of you understanding what I'm saying? That's why pitot tube is placed at the center line so that there is a no viscosity effect is there. Because of the no viscosity effect, it can measure the velocity what? Up to the accurate value. Understanding? All of you are understanding? Perfect. So just note down. Now, once it is done, then please let me know. Once it is done, then please let me know. Done, all of you? So guys, let me ask you one more question. So pitot tube we have understood, right? All of you have understood the pitot tube, right? Tell me, guys. So can I ask you one question? Very basic question. Very basic question, but very, very important question. This is the pitot tube, which is placed with the what? It is placed with the what? It is placed with the, piezometer. Now tell me, guys. And of course, fluid is flowing with some velocity V. My question is, what is the discharge through pitot tube? What is the value of the discharge through pitot tube? So here, let's suppose that we have the rise of height is h1. Here also same height is there, but additional rise is there because fluid is brought to the rest condition, and that we say h2. Here also same, it is h1. So here I can ask you two questions. That is the first question. Second question, what is the discharge through pipe? So for both, I'm giving the option. For both, I'm giving the option A. Now forget about this question. Focus on this question which I mentioned right now. The discharge value will be under root of 2gh2. Suppose diameter of the pipe will be d. That is the one value. Option B, discharge will be under root of 2gh1 pi by 4 d square, and pitot tube is going to have the diameter. Here the diameter is what? Let's suppose d2. C option. Under root of 2gh2 pi by 4 d2 square. Discharge value will be 0. So 4 option I'm giving to you right now, and just tell me the answer for first question as well as second question. Options are same for both first and second question, right? In fact, you can measure the height from, from here, because we can measure the height, right? Yeah. Tell me, guys. Very, very important. So whatever the H2 is there, we say, dynamic rise or dynamic head. H1 we can say is static head. So the total, whatever the height is there, suppose H, then H I'm calling stagnation head. Suppose I have calculated in terms of what? Meter. H is what? Meter. If you want to calculate the stagnation pressure, multiply with the rho g. Static head, multiply with the rho g. Dynamic head, multiply with the rho g H2. You will be calculating what? Dynamic pressure, static pressure, stagnation pressure. So this is pipe. You are talking about which? Mention the serial number also, 1 or 2. If you're just saying any answer, mention the serial number also for that question. Yes, guys, do not involve so much time. First is D. Excellent, guys. Excellent. So now try to understand, guys. This is the importance, right? Only learning the pitot tube, understanding the formula will not be sufficient. Remember, guys. So if I'll be asking you pitot tube, the answer will be 0, my dear friend. Absolutely correct. And what about the pipe? Pipe, you know that area into velocity, and you know that how to calculate the velocity? Under root of 2gh dynamic. And here, what is the dynamic height? What is the dynamic height? h2 only, right? So can I say this option will be A for second one? Area into velocity. What is the area? Pi by 4 d square. That will be the correct answer. Because suppose if you have not understood like this, only you understood the formula of velocity by applying the Bernoulli equation between point 1 and 2, you are in the wrong path. In GATE examination this year, what the question they have asked, they have given the pipe. In that they have placed uniform diameter tube. Most of the candidate, they thought that it is a pitot tube. It is not a pitot tube. They mentioned clearly in the problem, it is a uniform diameter. That means what? Here and as well as here, the diameter is same. When the diameter is same, how dare you can say that the fluid element will be what? Brought to the rest condition. Here the fluid element, you can say that brought to the rest condition because of the what? Very, very narrow area. The fluid is flowing like this, but it cannot flow. It cannot flow through this particular, pitot tube. Very slowly it will flow, almost with a negligible velocity. Here, whatever the tube they have mentioned, and they mentioned clearly that velocity. And they ask, what is the velocity? They mention already what? They mentioned that what is the velocity clearly in that picture. Through that also, somebody got the idea, velocity they mentioned, that means they have some options. And the option they have given, what is the discharge through this particular, tube, they ask. In fact, they did not keep the option 0. If I would have been there, I would have kept the option called 0 also, like this. And most of you will be tempted to think 0 answer, right? So all of you understanding the point, what I'm discussing right now? Yeah. So that is what whenever you're understanding any topic, do not think that you can learn from any sources randomly and that will be correct. So no. Remember, pitot tube means it cannot have uniform diameter. It has to be converged at one point. Other end, it is what? Open end or maybe uniform diameter, let it be. Now, come back to this question. Effect of compressibility of the fluid can be neglected if the Mach number will be what? Less than 0.4. Tell me guys, is it done? Is it done, all of you? Perfect. Now try to answer this question and tell me the answer. Air at 300 degrees centigrade at 7 bar is expanded isentropically until the velocity is 300 meter per second. Calculate the static temperature of the air at a high velocity conditions. So that is a very good question. Those who understood fluid mechanics, they can really, basically they can answer very comfortably this question. But before that, you must able to understand what is the meaning of static temperature and stagnation temperature, right? So just wait. Let me discuss one important point, then we can discuss about this question. Yeah, here onwards. Now try to understand stagnation properties. Whatever the stagnation properties are there, that we need to discuss. Consider the flow is flowing through the duct. Consider I'm discussing about stagnation properties. Consider a fluid is flowing inside the duct where the work done is zero. There is a no heat transfer. Work done is zero. There is a no heat transfer. In that control volume, if you just consider the control volume in that pipe, the work done is zero. There is a no heat transfer. Apply steady flow energy equation. All of you know steady flow energy equation. All of you are understanding the steady flow energy equation between 1 and 2, suppose. Tell me guys. And I'm assuming the steady flow. I'm not assuming the condition to be unsteady. I'm assuming the condition to be what? Steady flow. Now, while applying the steady flow energy equation, H1 plus V1 square divided by 2000 delta Q, that is equal to what? H2 plus V2 square divided by 2000 plus delta W. This will be 0. This will be 0. Suppose, my dear friend, suppose at the condition 2, we are bringing this body to what? This fluid element to be what? Rest condition. At 1, we are having the property called H and U, but at the condition 2, we are having velocity to be what? Velocity to be 0. Suppose velocity is 0. Then whatever the H2 will be there, that H2 will be converted to what? Stagnation enthalpy. So what is the stagnation enthalpy? It is basically what? It is basically the summation of enthalpy, static enthalpy, and what? Kinetic energy. Note down. Simply we can write H stagnation as H plus U square by 2. Whenever the fluid is brought to the rest conditions, then we say stagnation enthalpy. We simply represent it by H naught. We simply represent it by what? H naught. Note down guys, very, very important. Suppose in any device, there is a no heat transfer, there is a no work done. Then in this case, what will happen? H1 plus V1 square by 2, H2 plus V2 square by 2. And of course, potential energy we have neglected. Whatever the potential energy is there, that we have neglected. Under this condition, my dear friend, this is nothing but what? H01. This is what? H02. So can I say H01 will be what? H02. Stagnation enthalpy at the 1 point will be equal to stagnation enthalpy at the point 2. Check it out. By this. H stagnation is nothing but it's a combination of the H plus U square by 2, or we say that enthalpy energy and what? Static enthalpy and what? Kinetic energy. The summation is called as what? Stagnation enthalpy. Yes or no, guys? All of you please verify it. Perfect. Perfect. Now, if that is correct, my dear friend, so note down in any device, right? Suppose we are talking about the combustion chamber of the jet aircraft. In that case, there is no work done. There is no heat transfer. Suppose that, like in the diffuser section. In diffuser section of the jet aircraft, not combustion chamber. Combustion chamber basically heat transfer might be there. But in the diffuser section of the jet aircraft from missile or maybe jet engine, what you can see, there is no work transfer, there is no heat transfer. In that case, stagnation enthalpy will be what? Constant, my dear friend. Right? Stagnation enthalpy will be constant. Very, very important, guys. Please note down. That's the reason stagnation properties are very, very important in the what? Jet engines. Now, once it is done, let me know. From the thermodynamics, you know that H is what? Cp into T. H is what? Cp into T. Basically, my dear friend, Cp is constant or varying? Tell me, guys. Specific heat at constant pressure value is varying or constant? Varying. But if I'll say for the ideal gas, whether it is for the perfect gas, it is fixed or not? If I talk about the perfect gas, for perfect gas, it will be fixed, right? So enthalpy is a function of what? Temperature only. Understanding? For a perfect gas, enthalpy we can say H is equal to what? Cp into T. So similarly, what we can write? My dear friend. Similarly, what we can write? Here, what we can write, my dear friend? H will be H plus U square by 2, that is equal to what? H naught. So Cp into T plus U square by 2 will be equal to what? Cp into T naught. So here what we can write? Cp T minus of T naught will be equal to what? Plus U square by 2 will be equal to 0. Here T naught minus T, that will be equal to U square by 2 into Cp. From the thermodynamics, can I write Cp equal to R gamma by gamma minus 1? From the thermodynamics, for the perfect gas or ideal gas, can we write R gamma by gamma minus 1? Check it out. Please check it out. All of you. All of you, please check it out. Perfect. Perfect. Now from here, what we can write? From here, what we can write? T naught minus T, that will be equal to U square. T naught minus T, that will be equal to what? U square by 2. Now, here I am replacing U with the what? Mach number. Here I am replacing with the U as what? Mach number is what? U by C. From here, what is the Mach number? U is what? Mach number into what? C. So Mach number is square into C square by 2. R gamma by gamma minus 1. Whether it is clear up to this step? So we are actually getting the relationship between stagnation temperature and what? Static temperature. All of you are understanding? We are moving towards a relationship between one formula which can relate the stagnation temperature with the what? Static temperature. What is T naught? Stagnation temperature. What is T? Static temperature. Thermodynamic temperature. That is static temperature. T naught is what? The temperature rises of the fluid when the fluid is brought to the what? Rest condition. Now, further what we can write? My dear friend? For isentropic process, C can be written as gamma RT. Am I right? C square can be written as gamma RT. So R into gamma by gamma minus 1, T naught minus T, Mach number is square into gamma RT by 2. Check it out. This gamma and this gamma will cancel out. This R will cancel out. So from here, what we can write? T naught by T minus 1, that will be equal to, my dear friend, that will be equal to, my dear friend, gamma minus 1 by 2 Mach number square. So T naught by T 1 plus gamma 1 minus by 2 Mach number square. Check it out. So this is a formula that is a very, very important formula, guys. Many times in ISRO examination, they have asked this question. So this is nothing but the relationship between, this is giving the relationship between static temperature and stagnation temperature. Static temperature relationship between static temperature, stagnation temperature. Understanding my point? Suppose fluid is flowing, whatever the temperature of the fluid is there, that is a static temperature. Suddenly it is bring back to the condition where the velocity is zero. Suddenly, where the velocity will become zero, then whatever the temperature will be there, whatever the rise in temperature will be there, that is what T naught. Understanding my point? Whether fluid mechanics, whether these things are clear or not. Tell me, guys. Yes. Perfect. Perfect. So stagnation temperature will always be more than static temperature. That is the one thing. Now, one important point, this is only valid for only isentropic process. It is only valid for isentropic process, my dear friend. But, if I'll be asking you about this correlation, something from here to here, just focus on this. Try to focus on this. T naught, that will be equal to T plus U square by 2 Cp. This formula will be valid for only isentropic or for all process. This is only valid for reversible, that is guaranteed. Of course, adiabatic, forget about adiabatic, because adiabatic we already kept zero. So already adiabatic condition is satisfied. So this is valid for reversible, but this is valid for all the process, whether it is a reversible or irreversible. Some of you might be thinking, sir, why it is valid for irreversible process? My dear friend, we got this equation from our previous segment. Our previous segment is what? This one only. And in that only one condition we kept adiabatic condition. We never impose a condition called irreversible condition or frictionless conditions. In this equation, my dear friend, anywhere you come across about the frictionless process, let me know. Any conditional offer is there from the whether it has to be frictionless process? Check it out. Please check it out. Yes. No condition is there. Only one condition is there, adiabatic condition. So this equation, whatever the equation you are studying, steady flow energy equation, in that suppose you are keeping dq to be 0, remember this steady flow energy equation is valid for reversible and irreversible both. That's why I'm saying try to learn the subject in such a way that no question can be unaltered, untouched by you in the examination, because they can play with the option like anything. Understanding my point? What I'm saying? So that's the reason from there only we derive this condition. That's why we are saying that it is valid for reversible as well as what? It is valid for irreversible process also. Right? Note on, guys, very, very important. After that, we will be moving on to the relationship between stagnation pressure and static pressure. After that, we'll be moving on to the what? Stagnation pressure and static pressure. So one formula is this one. This is very, very important. Done, all of you? Can I move to the next segment? Perfect. Perfect. Now try to understand. For isentropic process, for you, all of you, let me give you one important tips. Whatever PV equal to gamma, PV to the power gamma is valid only for isentropic. So those who are thinking it is valid for adiabatic process, no, no, no. For applying this, the process must be reversible and adiabatic, right? So some of you, please note down, those who want to have the understanding, it is only valid for isentropic process. So there is a misconception that it is valid for adiabatic. No. For isentropic process, we know that T2 by T1 equal to P2 by P1 to the power gamma minus 1 by gamma. So from here, what we can write? Suppose T2 is a temperature where the fluid is brought to the rest condition. So we can write T naught divided by T, P naught divided by P to the power gamma minus 1 by gamma. So P naught divided by P can be written as gamma by gamma minus 1. Very, very important, guys. Please note down. The relationship between stagnation pressure and static pressure. Now, if you just want to write in terms of Mach number, that also you can write T naught by T from the previous formula. What is the T naught by T? 1 plus gamma minus 1 by 2 Mach number square. So you can write from here also. You can write from here also, my dear friend, to the power gamma by gamma minus 1. That also has been asked multiple times in ISRO examination. Very, very important, guys. Once it is done, let me know. Done, all of you? Is it done? Now I think you must be comfortable in solving this question, and let me know the answer, guys. Let me know the answer for this question. Air is expanded, suppose nozzle, maybe from the condition 1 to condition 2. At the condition 1, the temperature is what? 300 degrees centigrade, and the pressure is what? 7 bar. Is expanded isentropically until the velocity will become 300 meter per second. Calculate the static temperature at that location. If Cp value is given as 1 kilojoule per Kelvin or degree centigrade. Very, very important. At least try to participate. Seven bar, 300 degrees centigrade. From there, it is expanding to a velocity. Maybe inlet velocity you can assume to be negligible. They have not given, that means assume to be negligible. Try to calculate. Try to use steady flow energy equation. There is a no work done. There is a no heat transfer. Nothing is there. So H1 plus V1 square by 2. H2 plus V2 square by 2000. For air, we can write H to be what? Cp into T. If suppose real gas is there, we cannot write Cp into T. We cannot write Cp into T. H will be the function of temperature and pressure. But for air, we can write H is solely on the solely the function of what? Temperature, my dear friend. Now, so from here, what we can write? This is to be 0. Cp into T1 minus T2. That will be V2 square divided by 2000. Cp is what? 1. T1, we know that is 300 degrees centigrade. T2, we have to calculate. Velocity, we know that. Then from here, what you can calculate? (255 degrees centigrade). Check it out. All of you, please check it out. In that only, I'm asking you what is the Mach number. Then what you will say? Mach number at location 2. What is the Mach number? V2 divided by C. What is the C2? Under root of gamma RT2. Gamma is known to you 1.4 for the air. R is known to you. That is what? 0.287 kilojoule per Kelvin. And T2 is known to you. That already you have calculated. Calculate C2. Velocity already given. You can calculate watts. Velocity is what? 300 meter per second. From here, you can calculate the Mach number. Now, once you calculate the Mach number, you will be finding as 0.651. Note on, guys. Very, very important. Once it is done, let me know. All of you are understanding the subject or not? Now, once it is done, let me know. Once it is done, then please let me know. Yes. Perfect. Perfect. Now, so I'll be adding one slide. Just wait. Actually, I just need to write the categories of the flow. So if Mach number will be less than 0.3, less than or equal to 0.3, then we say it's an incompressible flow. Even though fluid is compressible fluid, but the flow will become what? Incompressible flow. Understanding or not? If Mach number will be less than 1, more than 0.3, but less than 1. More than 0.3, sorry. But less than 1, then we say it is subsonic flow. If Mach number is in between exactly equal to 1, we say sonic flow. In this case, velocity will become c. If Mach number will be less than 1.2, more than 0.8, then we say transonic flow. When it is in between 1 and 5, then we say supersonic flow. When Mach number is more than 5, you know that hypersonic flow. Understanding my point? All of your understanding? Now, once it is done, let me know. Done all of you? Done all of you? Note down the variation of the fluid velocity with the flow area. Note down the variation of the fluid velocity with the flow area. We can also write flow through variable area duct. Now, while discussing this concept, very important conclusion I just want to conclude from here. Can I say converging duct always to be said to be nozzle? Or expanding duct always to be diffuser? Whether true or false? When I say converging duct, converging pipe always to be called as nozzle, expanding section always to be called diffuser, whether it is true or not true. Direction is here. Understand? Note down. You know that the mass flow rate is equal to rho into A into velocity. Rho into A into velocity. So suppose in incompressible flow, when I talk about the incompressible flow, when I talk about the incompressible fluid, and of course incompressible fluid will become incompressible flow, density will be constant. So A1 V1 equal to A2 V2. The moment we try to decrease the area, the velocity will increase. The velocity will increase. The moment velocity will increase, then we say, what is the function of the nozzle? To increase the velocity. What is the function of the nozzle? To increase the velocity. That duct will be called as nozzle always. But if you just consider to decrease the velocity, when the area will become more, the velocity will decrease, and this duct will be called as diffuser. What is the function of the diffuser? The function of the diffuser is to decrease the velocity by the expense of increase in area. But the moment you are entering into the world of compressible fluid, these things are not true. These things are not true. These things are only true with respect to incompressible fluid. But the moment you are entering into the worlds of, compressible fluid, this phenomena is not valid. My dear friend, rho will also change here. Rho is also change here. If rho will change, along with area and velocity, we have to consider about the rho also, density also. In that case, you have one formula, note down. Change in area, m square minus 1. M is what? Mach number square minus 1 into dV by V. Suppose I'm considering one duct like this, converging duct like this. I don't know the name, whether it is a nozzle or diffuser, I don't know. My Mach number is what? More than 1. At the inlet section, my Mach number is what? More than 1. That means supersonic flow is happening through that particular nozzle, or suppose that converging duct. A supersonic flow is happening through this converging duct. Now tell me dA by A, whether it is a positive or negative, less than 0 or more than 0. For this converging duct, whether dA by A is more than 0 or less than 0. Tell me, guys. Please tell me. Less than 0. If that is going to be less than 0, my dear friend, if that is going to be less than 0, if that is going to be less than 0, this is what positive, this is what negative. What about dV by V? Will also be negative. Will also be negative. That means, suppose here velocity is V1, here velocity is V2, V2 will be less than V1. Same converging duct will be called as a diffuser. Understanding my point? In case of compressible fluid, you cannot say that the converging passage will always be nozzle. That is only true in case of what? Compressible fluid. No, guys, very, very, very important. Understanding my point? Supersonic flow, whether when it is happening through a converging duct, then this is the diffuser. Suppose subsonic flow is happening through diverging duct. Subsonic flow means what? Mach number less than 1. When Mach number will be less than 1, my dear friend, when Mach number will be less than 1, what about here? dA by A, m square minus 1 into dV by V. When Mach number will be less than 1, this will be negative, this will be positive. What about dV by V? What about dV by V? Will also be negative. That means what? Again, velocity is what? Decreasing. When velocity is decreasing, again we say it's a diffuser. So in case of compressible fluid, diffuser can be what? Converging duct, can be what? Diverging duct. Same happened with the nozzle also. Understanding my point? All of you are understanding my point, what I'm saying? Tell me, guys. Perfect. So note, guys, this is a very, very important, very, very important thing. Once it is done, let me know. Once it is done, please let me know. The last point. You want me to clarify the doubts about the last point or what? Subsonic part. See, subsonic part, why I'm saying that, whenever the subsonic flow is there, whenever there is a subsonic flow, that means Mach number is what? Less than 1. When Mach number is less than 1, put over here m square minus 1. Anything which is lesser than 1 will what? Suppose 0.8 square minus 1. That will become what? Negative only. This is negative. This is positive because area is what? Increasing. When area will increase, dA is what? More than 0. That means this is positive, this is negative. Overall, this term is what? This dB by V will be what? Negative, right? This is positive, this is negative. 2 by minus 3, that is what? Minus 0.67, right? That is what? dB by V. That means velocity is what? Velocity is what? Decreasing. Even though velocity is decreasing, that is a function of the diffuser. Here also velocity is decreasing, that is a function of the diffuser. But the converging duct and diverging duct, the naming will be given based on how the flow is happening at the starting, whether it is a supersonic flow or subsonic flow, because it depends on the Mach number, and the Mach number depends on what? Density, my dear friend. Understanding my point? Mach number is what? Inversely proportional to what? C. C is what? C is what? dP by d rho. how the density has been changes with respect to applying pressure. That is what dp by d rho, right? Earlier in compressible fluid, that is nothing. We are not going to bothering about density. Density will never going to be changes. So we just eliminated this term. We just say that it's a product of A into velocity. Whenever the area will decrease, the velocity will increase, the pressure will increase. But that is not true in the case of compressible fluid, right? Done, all of you? So this statement is false and false. It is true with respect to what? Incompressible fluid, incompressible flow, but with respect to compressible fluid, it is not true. Done? Done, all of you? So this relation is giving rise to how the area has been changes with respect to change in velocity, and how the change in velocity is happening with respect to change in area. And that is being related with the what? Mach number. Done? Done? Perfect. Perfect. Suppose Mach number is less than 1. Suppose Mach number is less than 1. By using this formula, m square minus 1 into dv, for this case, first case, I'm talking about the first case. Area is what? Decreasing. This is negative. This is also negative. Negative, negative will become positive. Anything, velocity will increase. That means what? That is a function of the nozzle. And that's why we are saying what? It is a subsonic nozzle. It is a subsonic nozzle, my dear friend. Velocity will increase. Mach number will also increase. What is the Mach number? Velocity by sound, c. V will increase. Mach number will also increase. Understanding my point or not? All of your understanding? Perfect. No, guys, very, very important. Now here, what is happening with the pressure? Pressure is decreasing. Pressure is what? Decreasing. When velocity will increase, pressure will decrease. Velocity will increase, pressure will decrease. Yes or no, guys? From the Bernoulli perspective also, you got to know that whenever the velocity will increase, pressure will decrease. Understanding or not? Yes or no? Yes or no, guys? When pressure will decrease, temperature will also decrease, density will also decrease. No, guys, this is a very, very important and fundamental things. Just note on the second figure. Just note on the second figure and try to conclude whether you're understanding or not from this area ratio formula. By this area ratio formula, are you understanding or not? Check it out. Right? You can understand why the temperature will decrease from here also. H plus u square by 2, that is constant. So whenever velocity will increase, H will decrease. H will decrease means what? Cp into T will decrease. Understanding my point or not? Understanding my point, what I'm saying? From there also you can understand why the temperature is decreasing, right? And why the pressure is decreasing? P naught by P, you know that 1 plus gamma minus 1 by 2 m square. From here, Mach number will increase, this term will increase, and pressure is what? Inversely proportional. For constant P naught, pressure is what? Inversely proportional, right? Of Mach number. Understanding or not? So many ways are there through which you can understand why the things are happening. Yes or no, guys? But if I'll ask you stagnation temperature, whether it is a constant or not a static temperature. If I'll ask you stagnation temperature, that will be constant, right? Stagnation temperature will be constant, right? Perfect. Now, from here, what you can conclude? Mach number is less than 1. So, dA by A, that will be equal to m square minus 1 into dB by V. So, area is what? Increasing. This is what? Positive. This is negative. Velocity will decrease. If velocity will decrease, Mach number will also decrease, because Mach number is what? Velocity by C. V will decrease, M will decrease. Mach number will decrease means what? Pressure will increase. Pressure will increase means what? Temperature will also increase. Very, very important, no doubt. So now once it is done, let me know. We can discuss few more points about this in compressible fluid. Now done. Is it done, all of you? Perfect. So similarly, conclusion you can draw for supersonic nozzle and supersonic diffuser also, right? So this is the condition for subsonic when the Mach number is less than 1. When Mach number is more than 1, you say that it's supersonic flow. Means Mach number more than 1 and Mach number less than 5. Now, so we will try to understand the more question about this one. One more question is there. Just take it as homework one. This one. This question. This is a very easy question. Try to digest this question. An aircraft is flying at a cruising speed of 250 meters per second at an altitude of 5000 meters, where the atmospheric pressure is what? 54 kilopascal. Ambient temperature is given. The temperature is first decelerated in the diffuser. There is a diffuser section. Then there is a compressor here. And then there is an engine. Try to use this, try to solve this question. On Sunday, we have the next class. I will try, I will explore this particular problem. Very easy problem, but it's a very easy one. But try to apply the logic. The first question they are asking, what is the stagnation pressure at the compressor inlet? At this section, they are asking. Tomorrow we don't have compressible fluid flow. On Sunday we have. So they are asking what is the stagnation pressure at this point. Sunday, I don't know the timing. I think you know. No, Sunday already we have the class last Sunday, but that is postponed, and that is what happening today. Again, next Sunday, the coming Sunday, we are having one more class on this compressible fluid flow. So that is the stagnation pressure at the compression inlet, and the next question is required compressor work per unit mass, right? For the stagnation pressure ratio, that is P02 by P01, 8. This is section 2. So one type of hint I have given to you. Use that hint and try to tell me the answer. So this red color which I am marking you, that is what compressor section is there. Before that, diffuser is there, and after that, aircraft engine is there. So based on the same, can you tell me what is happening? At the inlet, supersonic flow is there or subsonic flow is there? air which is entering into this one. See, we are saying diffuser, velocity is decreasing, area is increasing. What can be the at the inlet condition? Area is what? Positive. Velocity is what? Negative. Positive, negative, that means what? M square minus 1 will be negative. What about M? What about M? Sorry. It is resembling to which case? Check it out. It is resembling to which case? Where we have the diverging duct, but in the diverging duct, velocity is decreasing. Check it out. Diverging duct, but velocity is decreasing. Diverging duct, but velocity is increasing. So we have to take about the second case. In second case, what is the Mach number? Less than 1, right? So in the at the inlet condition, what is happening? Subsonic flow might be happening, right? Yes or no, guys? Yes. Perfect. So I think for today's session, that is a more than sufficient. Let me just leave this class by one question, last question. If you have the converging nozzle, suppose that, assume the condition, with the help of nozzle, we are able to increase the velocity. When we are able to increase the velocity with the help of nozzle, then why we need converging diverging nozzle? We say CD nozzle. If you have only converging nozzle, which can increase the velocity, then why to have the supersonic speed, to have the Mach number more than 5, we are using convergent divergent nozzle? Why? What's the reason for that? In fact, we have the nozzle in fact, we can have supersonic nozzle also, where velocity can be increased infinitely large. But why we are not using in the actual condition, why we are employing CD nozzle instead of C nozzle or converging nozzle? So with that doubt, I'm just leaving the class. In the next segment, we are going to start from here only, from that doubt only, why we need the convergent divergent nozzle, and there on we will continue, right? Yeah. So can't we achieve the supersonic in the converging nozzle? You want to say? Only with the help of converging section, can't we increase the velocity to the maximum value, more than 5 times of C? Yes. Yeah, flow is subsonic only. Suppose in both the case, CD and C nozzle, in both the case, the subsonic nozzle, subsonic flow is there. The subsonic flow, I need to convert to what? Supersonic. Remember, my dear friend, in the convergent nozzle, in the subsonic flow, in the subsonic nozzle, the first case, you can increase the Mach number up to maximum 1. You can get at the exit, you can get maximum to maximum what? Sonic speed. If you want to achieve supersonic speed, we have to attach the diverging portion like this. That's the reason we say C, D nozzle. Understanding my point? That is what our next segment will be, right? All of you understand this today's lecture comfortably? So most of the fundamental that will be asked in the examination that we already covered, but extra thing that is a bonus for you guys. Whatever the shock wave we are going to learn, normal shock, oblique shock, right? 2 types of shock is there. One is perpendicular to the flow. One is what? With the angle to the flow. The shock which are happening at the angle to the flow. Now it can be oblique compressive shock or it can be expansion shock, right? Why the missile shape is diagonal? Why the aircraft shape is what? Not diagonal. What are the difference between missile and aircraft? Why the shape is different? Supersonic aircraft is having different shape than the subsonic or maybe sonic or maybe supersonic aircraft. Why it is so? All the things are depends on what? how the shock waves are happening in that case. And why the shock waves are happening, that is also one of the important question, right? So done. Okay, guys, thank you, right? What you are asking, according to you. A paper, which paper? Which examination paper you are asking? ESC. Okay, so for ESC, basically,